Okay, let's go through recursive reprompting and revision. So this is from an old paper which specifically works with GPT-3. So it's a little bit dated now, but the fundamentals are still the same. This is like one of the most influential things I've read in terms of prompt engineering and understanding the systems of how you divide the task up to multiple things. The goal of this paper was really just to keep a coherent story when you're generating stories of arbitrary length, so things that can't all fit within the same prompt. And the idea they had, the way they did it, was they first recursively generated the ideas of the story. So they start with the premise. A new law grad returns home to start a career, but struggles with the broken justice system. So that's the premise of the story. And then everything else is generated. So they generate the setting, they generate the characters. And when they're generating the next thing, they feed in the previous things they already generated. So the setting gets the premise, but then the characters are generated based on the premise and the setting. And then the outline is generated based on the characters, setting, and premise. Then it goes to the drafting module, which I think is the most important, which is you go through the outline, the plot points, and then you just generate each one. And when you generate one, it feeds this information back in from the planning module. So it knows what happened in the previous section, what happened immediately before this section, what's about to happen, and then it generates the text. Then the rewriting part is just going through and finding any logical inconsistencies and then addressing them. So I haven't implemented this part exactly the same as them because I didn't build this like coherence and relevance ranking system, but you can do something similar if you want to. I found it's not necessary. It just depends on the story, but for me it worked fine just doing it this way. Cool. First, let's put in our API key. So you get the API key from here. I'm going to copy that across, and then you paste that in there. And then you want to make sure that OpenAI is installed. Okay, and then this is just to complete the prompt. So I've updated this. It was GPT-3 originally, and now I'm using the chat completion, which is GPT-4 or 3.5. So you can change the model here. All I'm doing is I'm not sending a system message. I'm literally just inserting the prompt as the user message. And then this is how you get back the response. So it's choices, and then you get the first choice, and then you get the message and the content. And just to check that's working. Yes, it's working. Cool. I input the premise, and I've just used the same premise as them. And then we generate the setting. So the prompt is the story is set in, and then you ask it to give you the actual setting. So the interesting thing is every time you run this is different. So this is in a rural town in Kentucky named Cedar Ridge. You could run it again and get something different. A small town in the Midwest. And if you set a different setting, everything else is going to be different. So the names of the characters, etc. as well. You could keep running this. So yeah, this is good. Blue Mountain in Kentucky. Sounds good. Cool. And then I'm going to generate 2 characters. And what this is doing is just looping through and then feeding in the premise, the setting, and the character format. And here we go. So we have Harper Davis, who's a determined 25-year-old. And then we have Donovan Donnie Grant, who's a 40-year-old. Yeah, typically, it depends on how many characters you include, but usually the first character is the main person. And then the second character is like the antagonist. Cool. Now let's generate the plot points. And what this is going to do is just generate like a list of the different things that happen in the story. And one thing I find is this typically follows the hero's journey. So they arrive in the town, they get into some trouble, they make friends and enemies along the way, and then lo and behold, they find that the strength to solve the problem was within them all along. So same as Star Wars, Harry Potter, The Matrix, Lion King, everything. So it's pretty cool that AI has learned that from our stories. Cool. She returns to her hometown, realizing that things have changed. She crosses paths with Donnie Grant. He's sly, whatever. And then she's in a battle to unravel the corruption. She collects evidence. She has a major courtroom battle, and then realizes the town's problems run much deeper. Cool. All right, pretty cool story, and you could just do this. You could run this again if you want something different. Cool. So that's the plan module, and now we go into drafting. So we're going to go through and split out the plot points, and this just basically splits them based on the new line and removes the numbers. So you can see here that these are the different plot points that we had. And then we're going to loop through each plot point. And when we loop through, we're going to do the same thing that the paper said, right? So we're going to give them the previous story summary. We're going to say immediately before the current passage, this is what the text was. And then in the upcoming passage, this is what is going to happen. And then the relevant context is like the characters, etc. So let's just see how this works. And you can modify this yourself, right? I think in general, this paper has been really powerful in teaching me what is possible and helping you understand a little bit like that you don't have to do everything in one prompt, right? We're doing hundreds of prompts here potentially, as we go through and iterate. I'm just going to let that run and see how we go. It should start appearing. Okay, cool. Yeah, plot point 1, that's the character that's saying in the upcoming passage. That's what's going to happen. It's going to keep generating that. So while that's generating, I'll show you the revision module so we get ahead on that. So while that's running, revision, and this is, I think, the one that's most open to interpretation because there's lots of different ways to do this. What I tried to do is I made my own little one. The general idea is that you could, AI, or for in this case, is actually much better at correcting itself than it is at writing the correct thing in the first place. It can tell if it's done something wrong if you feed the result back in. And that's the principle that we're using here. So what facts can be inferred from this text? We're pushing in the text and saying what facts can be inferred from this text, and we're starting with the first section and finding the facts from there, and then finding the next section, finding the facts from there, and then seeing if there's any inconsistencies. And if there are, then we say edit so there are any inconsistencies are fixed. So this is still generating. But there are different ways, obviously, you could do this, and you could build like a knowledge graph, you could embed it, you could build vector databases, whatever it is you need. But just to know, I think like it's important to understand that you shouldn't be afraid to just run back over everything you generated and fix any issues, because the chances are it will catch its own mistakes, which is pretty cool. So that's still generating. What plot point are we on? Okay, yeah, so it's just cross paths with Donnie, so we've still got a little bit of generation to do. So this is an example from another story where it's found some of these facts. They both moved back from their hometowns, so this is a different set of characters, as you can see. And then there's the new facts, and then it says consistency issue is that Toby had only just moved back to his hometown, and she had been practicing in the hometown for a while. So then they rewrote the text. Whereas in some cases, there is no inconsistencies found, so the text ends up staying pretty much the same. Cool, so that's how that works. Let me just see if this is done yet. No, it's still running. And then once that's done, then you basically just join everything together and you have the full story. Hopefully you understand the system. I'm not going to keep this running forever, but you can see how it's working. GPT-4 does have a lot of latency. It takes a few seconds at least for each call. Run it on your own. I think it would take for 5-6 plot points. It would probably take 10-15 minutes maybe. And then sometimes you'll run into rate limits as well. Oh, here we go. So that's finished. All right, now let's join these drafts together. This is great. It's even got some text, some quotes. Yeah, this is awesome. So it feels like a real story. Cool. And now let's try the revision, see if we find any inconsistencies. I'm not going to run this whole thing just because you can run it on your own and kind of spot what it's doing, but let's just wait until the first one comes up and then I can show you what that looks like. Just waiting for that to run. Just while that's running, just so you can understand what's going on here, we're looping through the index, And then we're starting on range 1, so we're starting after the first section. So this, when it says index -1, that is the first section. So it's giving you the text and then asking for facts. And then it's going to keep running. Now, the interesting thing here is that we're going from start to end. So the facts will build up and we'll have more and more facts. So one point of failure here is if you have a really long story, you'll end up inserting too many facts into the prompt. So there are different ways you can do this depending on your use case. All right, so here we go. So you have draft text 2, the old facts, and then the new facts, and there are no inconsistencies, which is great. And then it's going to keep going. Cool. All right, so hopefully you understand the gist of this. Feel free to read the paper. I've linked it in the top here. Really powerful paper. Play around with this yourself. You might find that different formats or different plans work better for your use case. But this is a great way to keep consistency, because every time you're calling OpenAI, you're passing in a lot of context from the previous story. And by the time you get to the end of the story, everything should be relatively consistent.